Welcome back. Today I'll be discussing about hinge loss for large margin classifiers. And last time we talked about single hinge loss for a single data point. Today we'll be talking about hinge loss for full data set. As you can see, we already had created a function for hinge loss for a single data point last time, which was called hinge loss single. Now, the hinge loss for full data set will be called hinge loss full. Hinge loss full takes four parameters: feature matrix, which is a matrix for data set; label for each data set; theta and theta zero. It's a linear classifier. For common section of hinge loss full, we have that says find the total hinge loss on a set of data given specific classification parameters. It takes arguments, feature matrix, a numpy matrix describing the given data. Each row represents a single data point. Labels, a numpy array where kth element of the array is correct classification of kth row of feature matrix. Theta, a numpy array describing a linear classifier, theta 0, a real valued number representing the offset parameter. This function returns a real number representing hinge loss associated with the given dataset and parameter. This number should be the average hinge loss across all the points with feature metrics. So how do we do this? Okay, so first thing we need to do is we need to create a list called hinge loss. We'll create a list called hinge loss. We are creating this list because it's easier to work with matrix list than array, numpy array. Later we'll convert this list into numpy array to find an average. Now we have to iterate through each row in a matrix, and each row represents a single data point. For that, we have to find the number of rows in a matrix. And how do we do that? NP. So let's say rows num equal to, let's say it is called NP, which is numpy, shape of the matrix, and we'll take feature matrix as input, feature matrix as an input, and zero will be the number of rows for that. That's a row num. Now we'll do the for loop for each of the rows, starting with I in range, and row num will be the parameter that we'll take. Then we will iterate through each row and calculate the hinge loss for each row. So that will be hinge loss dot append, and we'll use the function that we created earlier to calculate the hinge loss that for each data point. So it's going to be hinge loss single, and the parameter that it takes is, it takes four parameters. Hinge loss single takes four parameters: feature vector, label, theta, and theta 0. So the feature vector is the is a one given row. So feature vector is a single row in the matrix. That's called feature vector. So how do we do this? How do we do this? We will do is what we will do is we will take the feature matrix and take the one single row for that. So let's take this matrix and we'll take a single row. Okay. So this is a single row of that matrix. So that's the first parameter. Now we'll input the label for that. Now input the label for that, and now we'll input the theta, which is our classifier, and then we'll input the offset parameter. So these are the things we need. So it's going to be labels, not label. So labels is basically a numpy array. The kth element of array is the correct classification of kth row of the feature matrix. So we'll use the labels, which is the classifier that we need. And once we do that, now we have the hinge loss appended into a list. Now we'll convert this list into a hinge loss array. Hinge loss array. So what you do is np dot array hinge loss. That's how we're gonna do it. So now we have a hinge loss. Now next step is to return this numpy array by averaging it, and which will be our result that we need. So numpy dot average, that's how we do it. This is the way to actually create the hinge loss function for a full data set. So let me quickly summarize what we did today. We created a hinge loss function for a full data set, and for that hinge loss function, it requires 4 different inputs: feature matrix, labels, theta, and theta offset, which is theta 0. And by using the hinge loss function for single data point, we calculated hinge loss for a full data set, and we return the average of that hinge loss for each data set and return as a single point for a hinge loss flow. Thank you so much.